In the grand theater of the cosmos, nestled between science and myth, lies a constellation that many have overlooked. It's a figure that challenges our traditional celestial maps and holds within its boundaries some of the most fascinating objects in our galaxy. Today, we conduct a deep dive into the constellation Ophiuchus, the serpent bearer.
Now, Ophiuchus is far more than just a pattern of stars. It's a celestial enigma, really. It poses a question that strikes at the intersection of astronomy and astrology, a field from which we, as scientists, have long since diverged. But the question remains, and it's a valid one from an observational standpoint. If the sun's path clearly travels through Ophiuchus, why is it excluded from the traditional zodiac?
To answer that, we need to discuss a fascinating but very slow astronomical phenomenon called axial precession. Picture the Earth as a spinning top. You know how a top wobbles slightly as its axis of rotation slowly traces out a circle? Well, the Earth does the same thing, just on a timescale of about 26,000 years. This slow wobble means that our vantage point from Earth shifts over the millennia. Consequently, the zodiac, which was defined by the Babylonians over 2 millennia ago, is no longer aligned with the constellations as we see them today. And this celestial drift is precisely why the sun now spends a significant amount of time in Ophiuchus.
So here's our roadmap for today's exploration. We'll start with the 13th sign controversy itself. Then we will move into the astrophysics, treating Ophiuchus as a laboratory in the sky. After that, we'll examine the rich myth of Asclepius that gave the constellation its name. We'll touch on its legacy through the ages, and we'll conclude with a practical guide for observing the serpent bearer yourself.
All right, let's begin our inquiry. We'll start with a straightforward astrometric profile of this celestial giant.
The first thing to understand is that we are not talking about some minor, obscure star pattern. Ophiuchus is immense. It covers over 948 square degrees of the sky, making it the 11th largest of the 88 official constellations. Its equatorial location means it's visible from almost anywhere on Earth during its peak season in June and July. So this is a major celestial player, hiding, as it were, in plain sight. Now, let's set aside the zodiac debate for a moment. From a purely astrophysical perspective, Ophiuchus is absolutely fascinating. It offers us a remarkable window into the lives of stars, from their violent births to their cataclysmic deaths. It's truly a laboratory in the sky. Okay, to appreciate some of the wonders within Ophiuchus, we first need to grasp a key concept: proper motion. You see, stars are not fixed points of light. They are all moving through space at incredible velocities. But because they are so profoundly distant, their movement is nearly imperceptible to us. Proper motion is the measurement of that slow, apparent drift across our line of sight over many years. And the poster child for proper motion is, without a doubt, Barnard's star, located right in Ophiuchus. This star exhibits the largest proper motion of any star in the sky. The reason? It's incredibly close to us, just under 6 light years away. To put that 10.3 arc seconds per year figure into perspective, over the course of a single human lifetime, it will appear to move a distance in the sky equal to half the diameter of the full moon. A stellar sprinter, in cosmic terms. Ophiuchus was also the site of a truly historic astronomical event. In 1604, a new star suddenly appeared. It was so bright it was visible during the day for over 3 weeks. This was, in fact, a supernova, and it was meticulously documented by Johannes Kepler. It remains the most recent supernova to have been definitively observed with the naked eye within our own Milky Way galaxy. Today, we study its remnant, a powerful source of X-rays, to better understand the physics of these Type Ia explosions. And now for what is arguably one of the most visually stunning objects in our galaxy. This is the Rho Ophiuchi cloud complex. At only about 460 light-years away, it's one of the closest stellar nurseries to our solar system. What you're seeing here is a breathtaking cosmic canvas. The dark, opaque regions are dense lanes of interstellar dust, obscuring the light from behind them and serving as the cold cradles for protostars. The brilliant blues are reflection nebulae, where light from young, hot stars is scattering off finer dust. And the reddish pinks? That's glowing hydrogen gas, energized by the intense radiation from those same newborn stars. The wonders don't stop there. Ophiuchus also contains a fascinatingly volatile system called RS Ophiuchi. It's a recurrent nova, which means it undergoes periodic dramatic explosions. Here's how it works. You have a binary system, a large bloated red giant, and a very dense compact white dwarf. The white dwarf's immense gravity pulls material, mostly hydrogen, from its companion. This material spirals down, forming an accretion disk, and eventually piles up on the white dwarf's surface.
When enough material accumulates, the pressure and temperature reach a critical point, igniting a runaway thermonuclear explosion. The system brightens hundreds of times, then fades, and the whole cycle begins again, roughly every 15 to 20 years. All right, having explored the astrophysics, let's now shift our focus from the scientific to the symbolic. We'll delve into the foundational myth associated with this constellation, which is every bit as dramatic as the celestial events we've just discussed. This is the story of Asclepius. The myth begins, as many Greek myths do, with tragedy. It involves the Olympian god Apollo and a mortal princess, Coronis. When Apollo discovered she was unfaithful, he struck her down. But as she died, he learned she was pregnant with his son. In a moment of despair and remorse, he performed a miraculous cesarean section, saving the infant Asclepius and entrusting him to the wise centaur Chiron for his upbringing and education. Under Chiron's tutelage, Asclepius became an unparalleled physician. His knowledge took a legendary leap forward because of a key observation. He witnessed one serpent bring another back from the brink of death using a specific herb. By learning this secret of nature, Asclepius transcended mere healing. He gained the power to reverse death itself. The serpent thus became his symbol, and the serpent-entwined staff, the rod of Asclepius, remains a symbol of medicine to this day. This incredible power, the ability to resurrect the dead, was a profound disruption to the cosmic order. It threatened the very boundary between mortals and the divine. Hades, the god of the underworld, protested to Zeus that his kingdom was being depopulated. Fearing that Asclepius would teach humanity the art of resurrection and make them immortal, Zeus acted decisively. He hurled a lightning bolt, striking Asclepius down for his hubris. But the story doesn't quite end there. As a tribute to his fallen son, and perhaps to appease Apollo, Zeus granted Asclepius a place among the stars. His placement in the heavens is deeply symbolic. He is depicted grasping the serpent, Serpens, which is represented as a separate constellation divided into two parts by his body: Serpens caput, the head, and Serpens cauda, the tail. This shows his mastery over life and death. Furthermore, he is positioned standing on top of Scorpius, the very creature whose venom killed the great hunter Orion, a sign of his eternal role as the ultimate healer. So, we have this rich myth and we have the rich science. Let's now briefly look at the history of how this constellation has been documented through the ages. This isn't some newly defined pattern of stars. If we look back through history, its presence is consistent. In the 2nd century AD, the Greco-Roman astronomer Ptolemy cataloged it in his definitive work, the Almagest, as Ophiuchus. Through the Middle Ages, the Latin tradition knew it as Serpentarius. And then, in 1930, the International Astronomical Union formally defined its modern boundaries, cementing its official status and, in the process, confirming that its territory is indeed crossed by the ecliptic. All right, let's bring this out of the theoretical and into the practical. For our final section, we'll cover a guide to finding Ophiuchus in the night sky for yourself. Any observation begins with finding the key signposts. For Ophiuchus, these are its brightest stars. You'll want to look for Russell Hug, its alpha star, which marks the head of the serpent bearer. It's relatively close, only 47 light-years away. Then there's Sabik and Han, two other prominent stars that help sketch out the main pentagonal or bell-like shape of the constellation spot. So where exactly do you look? Well, the trick is to use other, more familiar constellations as your guides. First, find two celestial landmarks: the bright star Vega in the constellation Lyra, and the unmistakable J-shape of Scorpius, low in the southern sky during the summer. Ophiuchus occupies the vast territory directly between Hercules and Scorpius. Look for its large, sprawling shape. And if you have a pair of binoculars, you are in for a real treat. Scan the central region of the constellation. You should be able to spot two beautiful globular clusters, Messier 10 and Messier 12. They'll appear as small, fuzzy patches of light, each one a compact city of hundreds of thousands of ancient stars. Ultimately, Ophiuchus serves as a powerful reminder that this sky is not a static, unchanging backdrop. It's a dynamic environment, a place of constant change driven by fundamental physical processes. The controversy, the science, and the myth all compel us to look closer, to question ancient assumptions, and to appreciate the intricate universe we inhabit. So I leave you with this thought. The next time you gaze upward on a clear night, look for the serpent bearer, and consider what other stories, what other scientific truths are waiting there to be discovered.